This presentation shows how to use XOM. XOM is an abbreviation for execution-only memory. Nuvoton new micro M2351 chip adds the feature XOM to help developers protect their own code and enhance the security level. What is XOM? XOM allows only instruction fetches. Read and write accesses are not allowed to access XOM region. Because of such a hardware behavior, the XOM region seems to become an invisible area. Whether using Flash tool or using firmware to access XOM will eventually only read to 0xFFFFFFFF. Why use XOM? XOM is the firmware protection technology to protect like as an important program, data, algorithm, or digital security key that need a high degree of security level. Because of XOM's protection, first developer can give XOM API function files to a secondary developer. The secondary developer can call XOM inside the function or data easily. The XOM will make code development projects safer and easier. The M2351 provides 4 XOM region settings for users to flexibly use to share 510 KB inside the M2351 flash space. One XOM region can use flash memory up to 510 KB. There are 3 XOM control modes: off mode, debug mode, and normal mode. When the XOM region is in normal mode, ICE cannot be used for single-step debugging. The M2351 offers XOM debug mode in particular, allowing developers to single-step debug in the XOM region. More importantly, the code in the XOM region will not be displayed on the compiler's window during debugging. This feature will make debugging in the XOM region safer. When configuring the XOM region, user needs to set the start address, page count, size, and control mode at the same time, and finally resets the chip. After the chip reset, the XOM region will be active. Because the code on the XOM region needs to be executed only, the Kyle compiler has an execute only code option that allows users to set easily. The user can find the XOM settings page in Kyle's option page. Under the page, user can set the XOM start address, page counts, and whether to enable debug mode. Finally, click OK to reset chip and activate the XOM region. The video here demonstrates the XOM settings and use. The hardware requirement for using the XOM example includes the new Microcortex M2351 chip and Nuvoton New Link debugger. As to software requirement, use Kyle MDK v5.23 version or later, and install the Nuvoton New Link Kyle driver 6670 version or later. There are some limitations and recommendations on configuring and using the XOM. 1. XOM region start address can only be set in AP-ROM, and XOM region cannot be set out of AP-ROM. When configuring XOM region, the start address, page counts, and control mode need to be set at the same time. XOM regions can only use XOM page erase or whole chip erase. When using XOM page erase to remove XOM, a correct XOM start address needs to be set. Multiple XOM regions cannot be overlapped. XOM region start address should be page alignment. XOM region start address cannot be set at 0x00000000. When configuring XOM is failed, use whole chip erase to remove XOM region and settings. ICE cannot step in XOM only if debug mode is enabled. This video shows XOMlib and XOMlib demo sample application using the M2351 BSP to demonstrate. First, click the Kyle project files of XOMlib sample code to open the Kyle IDE interface. This sample program contains 3 groups, including CMSys, user, and library. Under the user group, there are 2 files, main.c and xom.c. Click and open xom.c, which includes 5 API functions: add, subtract, multiply, divide, and add up. The 5 API functions are specified and placed in the XOM region. Because the XOM region can only execute instruction fetches, first, compile the xom.c settings into an execute-only type of code. Click xom.c and right-click to open xom.c option settings window. Click the C, C++ AC6 page, and check Execute-Only Code option in the middle of the page. Then click OK to complete this setting. Open the main.c, and the program will first include the XOM API.h file. This file is the prototype declaration of the 5 API functions in XOM.c. The main.c is used to demonstrate how to call the API functions in the XOM region to perform mathematical operations, and finally output results. Specify the address of the XOM API function on flash memory before compiling. So user needs to use the scatter file to specify the address of XOM API function on the chip. Click Project, Option, Linker, Edit to open the XOM scatter.xcf file. User can see that XOM0 is assigned to the address 0x10000 and XOM.o is placed inside the XOM0 area. Close the scatter file and compile program. After the compilation is completed, user must prepare to download the code to the chip. First, user needs to set the chip type and flash download settings. Select Project, Option, Debug, Settings, Chip Type. Select M2351. Then click OK to leave. Select Project, Option, Utilities, Settings. In the page, check Erase Used Sectors, Program Flash, Verify Flash, Reset and Run, and then click OK to close the page. After completing the above flash download settings, click the Download button to download the code to the chip. Then, continue setting XOM. Click on the flash download page. Click the Setting button in the chip setting box to enter the M2351 chip configuration page, and select the XOM setting page. On this page, user can configure XOM0 to XOM3 for start address, size, and control mode. Here, only select XOM0 and then set the starting address 0x00010000 and the use of one page, 2 KB. Next, the following will demonstrate the use of XOM debug mode. Check debug mode then click OK. The message whether to modify the chip settings will appear, and then click OK. The chip settings will take effect immediately. Close all the settings windows. Prepare for XOM debug mode demonstration. Enter Kyle debug mode first. Open the main.c and set a breakpoint. Execute the program and stop at the breakpoint location. Run single-step debugging. After the program calls XOM API function, the program will run to the XOM API function address so that user can trace XOM API code. In this assembly window, the code of the XOM region is displayed 0xFFFFFFF. Leave Kyle compiler debug mode. Click Download button or F8 to start to download the code. The new link message will pop up at this time, warning the download code will cover the XOM region. Click OK to start to download the program. This operation will clear the XOM region and settings and then reload new code on the chip. Finally, demonstrate the XOM normal mode settings. Re-enter the XOM settings page. Please check XOM 0. Specify the start address 0x00010000. Set the size to 1 page and uncheck the debug mode. Click OK, and the message whether to modify the chip settings will appear. Click OK to close this window and XOM settings take effect now. Prepare for XOM normal mode debug demonstration. First, enter Kyle compiler debug mode. Open the main.c and set a breakpoint, and execute the program to the breakpoint location. Then use single-step debugging. After calling XOM API function, the program will immediately get the return result and will not run to the XOM API function code address. After compilation, the XOM lib sample code will generate a lib directory and 2 files. xomlib.h and xomlib.o. Click the xomlib demo project to start the Kyle IDE environment. Click Project, Option, C, C++, AC6. Include paths. The xomlib demo example program will include the xomlib lib path to the compilation search. Click OK to close the setting window. Open the main.c and include xomlib.h API function declaration. Then, compile the program and download the program to the chip. Enter Kyle compiler debug mode. open the main.c and set the breakpoint and execute the program to the breakpoint location. First, use single-step debugging. After executing the call XOM API function, the program will immediately get the return result, will not run to the address of the XOM API function code, and get the correct operation result. The XOM demonstration ends here.